Good day. My name is Tony Ziade. Welcome to Time Travel. Today we're going to talk about why time travel is an actual possibility in our realm of the universe. One of the first major things we're going to look at is time in and of itself. What is time? And how is it going to be manipulated to make time travel possible? Now there have been many great theorists before us who have come. One of them is Einstein. He's the most major physicist that everybody knows. He's famous for the equation E equals mc squared. Unfortunately, the whole entire E equals mc squared is not what is not actually correlated with his most famous theory, and that is special relativity and general relativity. In fact, let me go ahead and just give you a quick background of general relativity and what it truly means. First of all, when we look at time, and we think of time travel as just a manipulating of just one dimension, right? Going back and forth in this idea called space. Well, Einstein kind of put the nail to the coffin by formulating the idea that space and time are one unit. And together, they don't act as two separate units, but they are one mesh, one single unit that we as humans have failed to understand for the last, since the beginning of our existence. The whole entire idea of general relativity tells us that space is not only twisted in with time, but is more like a meshing of a fabric. Okay, and the whole entire equation E equals mc squared talks about the energy that kind of is inside of that. But the more important equation for general relativity is the idea that mass attracts other mass through this idea called gravity. While gravity in and of itself is really space-time. So if you want to substitute gravity for what we call space-time, this is the best way to do it. This is the best way that we can actually fundamentally look at how to manipulate time in and of itself, because time and space are one unit, right? So how is it that we come to understand this? Well, every atom is built up with tiny little bits of particles called protons, electrons, neutrons, and even further there are smaller little bits called quark atoms. Now, we're not going to actually look at the quark atoms today, but the most important idea is that matter creates gravity, right? And so the whole entire idea is that as things exist that we know, like the moon, our earth, the sun, all of this regular matter creates and attracts other matter of itself. And it absorbs space and time in and of itself. So you really think about it, the earth is pulling down space and time together. And on different planets that have different mass, because of the idea of space-time, the gravity is different, which means space-time travels at a different time, which means that time itself travels faster on bigger planets. Now, how is it that this happens? Well, that's the whole entire idea of understanding what time travel really is, right? It's the same idea of what is the human existence? Why are we here? Why are we placed on this universe? Those are questions that are very, very fundamental, and only you can answer those. One of the biggest parts about making time travel actually possible is through a gentleman called Schrödinger. And Schrödinger is a very famous physicist and philosopher. And it's funny because the two are very complex and related somehow. But the biggest thing that Schrödinger actually really came up with is what they call Schrödinger's equation and Schrödinger's box. And Schrödinger's box is one of, I think, the funniest ideas. And it's funny because it's realistic and simplicative, but yet complex. The whole entire idea is that there's a cat that is within a box, right? And there's a nuclear reactive atom that is floating inside the box, and once it decays, it sets off poison and it kills the cat. Well, after a certain amount of time, The question is the cat alive or dead? Now, at first you're like, well, is it one or the other? But Schrodinger came up with such a crazy idea. It is D, all of the above. The cat is alive and dead. But most importantly, we actually influence. Our minds and our perspective of reality influences whether or not the cat will exist or not exist. Very strange questions, I think, for humanity to actually answer. But this actually goes back to quantum mechanics. And when you shoot a particle down in actual strobe, and they've put up a couple of different slits and they've done several different experiments. Well, when they shoot the photon down a one slit path, what happens is that it creates just a regular wave pattern. Now when they put a double slit formation for the photon and then they shoot it, what they notice is that there's a double wave pattern that occurs on the end. And why is this really important? Well, what it is showing that nature itself is actually manipulating time. That the photon is actually in two different places at once. Now, why is it that nature can break its own rules? For us, we can only be at one place and at one time, and why can't we be in two places at once? It would make life a lot easier. I could be at school, I could be at work, I could be even cleaning my bathroom, all at the same time. But unfortunately, there's something that's going on that we are not able to understand yet. And the whole entire idea behind it is that when we're actually monitoring nature in and of itself, we start to see why it's able to manipulate time in and of itself. You know, the cosmos are, we think of this big vast space of nothingness, and that's not particularly true. 70% of the cosmos is made of what they call dark matter and dark energy. What is dark matter and dark energy? We're still trying to find that out. Physicists don't yet understand what it is. But I do have one clue to give to you, is that, you know, when you look at dark matter and dark energy, it is the complete opposite of what we know in terms of energy and molecular structure. And what I mean by that is that the atom in and of itself is inverse to what we know. Typically, our atoms here on Earth and within this realm of cosmos, the proton is positive, we have a neutron in the center of the nucleus, and the electron in and of itself is a negative charge. This is a very fundamental key aspect. But in dark matter, it's the complete opposite. So what we're doing is we're looking at 70% of the cosmos that instead the center is negative. The proton has a negative charge, and the electron has a positive charge. Now, from this we can deduce that possibly gravity is not exerted inward, or should I say space-time, but is outward. And why is this very, very important? The idea is that when you look at massive stars through the cosmos, they are consuming space-time, okay? And as time goes on, and you kind of stretch out and go a little bit further into the cosmos, the universe is expanding. It's expanding because dark matter and dark energy is pushing the universe apart. And it's pushing the universe apart faster than the speed of light. And why is that so important? How is it that things can go faster than the speed of light? Well, first of all, we as humans only know one thing that can go at the speed of light, and that is the speed of light. Nothing comes even close to the speed of light. It is the ultimate speed limit of the universe. But it shows that there's a correlating force that can actually overcome the speed of light in terms of being able to push and expand the universe. This energy actually holds more energy than what our regular matter holds. And when the two come together, there can actually be a huge decisive part of energy flow. And why is this really, really important? Well, if we go back to the very first main part, Einstein kind of was able to formulate why we may not be able to travel to the speed of light, and that is because we need a tremendous amount of energy. Now, we've been able to make dark matter momentarily, I shouldn't even say momentarily, for a millisecond inside of the particle accelerator lab. This is very, very important because we were actually able to reproduce part of nature inside of these very specific conditions. But when they come in contact, the amount of energy that's given off is enough energy to actually push a ship with humans on it into actually past the speed of light. This is the most important fundamental part, that we actually have an energy source that one day may be quantified inside of an engine that will give us enough oof to go past the speed of light. And why is that important? Because Einstein has actually really theorized that when we hit the speed of light, time is at a standstill. When you look at all the stars and everything around, and you start to understand that light travels at a very, very fast rate. Well, this is how fast light travels. Something like 186,000 miles per second. That's fast. So that's typically right around 7 times the globe in 1 second. To travel even to the next star would take hundreds of years. That's how far the universe is. We need that kind of source of energy in order to push us, in order to make it to the next realm, to the next galaxy, to the next planet. More importantly though, when we actually put a huge twist inside the space-time fabric, we can begin to warp the actual time itself. And this is done through what they call laser pointing or laser beaming. And what scientists theoretically theorize is that if we have enough energy through a whole bunch of different lasers and we focal point it through one tiny point in space, we can create what they call a wormhole and actually twist the fabric itself. The cool thing about this is that it is so far out there, you're like, this is never going to happen. But when you look at the way that humanity will progress in the next 100 years, we may end up having the technology to create our own stars, to dematerialize stars. Dr. Kaku actually talked about the different stages that humanity will have to travel in order to get to time travel in and of itself. This is such a big deal. The reason why is because humanity will not be able to exist forever on Earth. At the rate that we're multiplying, we probably will have to travel to a different planet. And it probably will be outside of outside of our galaxy. And how will mankind survive the next phase? And at first, you're like, okay, well, time travel, how is this going to really come together? And is it really that impossible? And the idea is absolutely not. It's actually here to stay. I think one of the biggest sources to actually really look at is that quantum entanglement and quantum teleportation. The whole entire idea behind it is that when we look at all the atoms that make us and bind us together, we've come to realize that every atom has a sister atom. And what that means is when we affect one atom, we instantaneously affect the other atom. Now this kind of goes along with quantum mechanics and Schrödinger's box. And that scientists have just learned that, if you can actually store information on one atom, then you can actually store information on the other atom. And why is this so important? Because if they're further apart than what speed of light can travel, then technically you're sending information back in time. So that's another concept that shows that this stuff is for real. This stuff is a possibility. And more importantly, we have to continue developing and research. Now, I don't have necessarily all the keys to say that time travel is going to happen here in the next 100 years, 200 years, but the whole entire idea behind this is self-discovery. The universe has put us here for a reason. We don't exist and wake up and drive in morning traffic for nothing. The universe wants us to be here. We are the universe. And why wouldn't the universe want us to continue our existence within its plane? For we recognize the universe for what it is. And I really urge everybody to take a look at physics. And even if you don't want to dive into the theoretical mathematics, which takes years to get to. I've taken some of the math courses that require, and it's really interesting. And the more I dive into it, the more I become baffled at human existence and what we really are and what is the meaning towards us being here. And I can't answer any of those questions for you. I can answer it for me. And for me, the pursuit of knowledge is greater than any other source that we can feed ourselves. It's greater than food. It is the source of the spiritual flame. And I encourage everybody to take a look at, what creates us, what binds us here. How is it that we exist? And try not to take anything for granted. Because the minute you take something for granted, you could be completely wrong. Remember that the world around us, buildings, trees, it's all space anyways. And what does it really mean in the end? So enjoy your time here on Earth. Pursue knowledge, pursue greatness, and do great things. Thank you so much.